Lesson 15.7 is about combinations. So our objective is to find the combinations of a set of elements. A combination of items occurs when the items are selected from the same group. No item is used more than once, and the key thing is the order of the items makes no difference. So that's what distinguishes combinations from the previous lesson, which was permutation. So keep in mind here that order does not matter. So a formula to find the combination of n things taken r at a time is n factorial over n minus r factorial. So the way that we pronounce this is n choose r. And sometimes you also see it written like this, just n over r in parentheses, and we still just say n choose r. That's the same formula, n factorial over n minus r factorial. And I'll probably write it in this way more often than not, just because it's a little bit shorter and neater and easier. Example 1, of these 5 people, 3 are selected to be included in a documentary. How many documentaries could be made? Okay, so the order doesn't matter here. We're gonna pick 3 people to be in a movie, but like, who cares who we show first in the movie or second or third? It's still a movie about those 3 people. We don't care what the order is. In that case, it's a combination. So we would use the formula n choose r, where we're choosing, oops, let me show this. We have 5 people and we're choosing 3 of them. So 5 choose 3. So in that case, we would have 5 factorial over 5 minus 3 factorial times 3 factorial. So that's 5 factorial over 2 factorial over 3 factorial, which I'll show the longhand work for this one. That would be 5 times 4 times 3 times 2 times 1 over 2 factorial is just 2 times 1. And 3 factorial is 3 times 2 times 1. So we can cancel out or reduce those to 1. And what we're left with is 20 in the numerator and 2 in the denominator. So 10. So 10 different documentaries could be made of different combinations of those 3 people. Let's just do quick practice just in this notation here really quick. So this first one says 6 choose 1. That would be the same as me writing it like this, 6 choose 1. And either way it means 6 factorial over 6 minus 1 factorial, 1 factorial. So that's 6 factorial over 5 factorial. 1 factorial is just 1, so I'm not going to write that, which would be 6. Here, 12 choose 5, we could also write as 12 choose 5 in parentheses like that. And that's going to be the same as 12 factorial over 12 minus 5 factorial, 5 factorial. In other words, 12 factorial over 7 factorial, 5 factorial, which is 792. Okay, this says how many combinations can be formed from the letters of solve, taking them. Let's first do a 2 at a time. So that's 5 letters in the word solve, and we're choosing 2 of them. So we could also just write it as 5 choose 2. So that's 5 factorial over 5 minus 2 factorial, 2 factorial. So that's 5 factorial over 3 factorial, 2 factorial, which is just going to be 10. Now, let me show you the longhand version of this just one time so that you can see what it is we're actually doing when we're taking a combination. So 2 at a time, if I was to take 2 letters, so like let's first group up S with each letter. So S can be grouped with O, S can be grouped with L, S can be grouped with V, and S can be grouped with E. Now, I'm not going to count those twice. Like, for example, SO would be the same as OS. So I'm not going to list the other order. Order doesn't matter. You know, SL is the same as LS. I don't care about order. Then we could group O with everything. So we already grouped O with S, so we'll group O with L, O with V, and O with E. Then we'll group L with everything. So it's already been grouped with O and S. So now we'll group L with V and L with E. And then finally we can group V with E. So those are the 10 different combinations. Again, order doesn't matter, so we're not going to double count SO and OS, for example. Okay, so now let's go ahead and choose 5 at a time. So that would be 5, choose 5. Or if I write it this way, 5, choose 5. Which is going to be 5 factorial over 5 minus 5 factorial. 5 factorial, which is just 5 factorial over 0 factorial is just 1, so that goes away. So it's 5 factorial over 5 factorial, which is 1. Which makes sense. If we're grouping all 5 letters and we don't care what the order is, then there's only one way to group up all 5 letters. Example 4. How many different starting lineups are there for a 12-person basketball team? So, a starting lineup, first of all, in basketball, has 5 starters. And it doesn't matter what order they go out on the court. You're just going to send 5 people out there. It's not like baseball where a certain guy goes first, batting, second, third. In this case, order doesn't matter. We just send 5 guys on the court. So in that case, we have 12 players to choose from. We're choosing 5 of them. So we're doing 12, choose 5. So that's 12 factorial over 12 minus 5 factorial 5 factorial, which is 792 different starting lineups we could have. Example 5. A school is choosing the honor board committee out of 9 teachers and 7 students. How many different committees can be selected from the membership if part A, we're going to make a 6-person committee. So in that case, we have a total of 16 people, right? We have the 9 teachers and 7 students, and we're going to choose 6 of them to be on the committee. So that's 16, choose 6. So that's 16 factorial over 16 minus 6 factorial. I'll just write 10 factorial times 6 factorial, which is 8,008 different committees. What if, though, we put some more requirements on it? We said, well, the committee has to have 3 teachers and 3 students. Let's focus on the teacher part first. So there were 9 teachers, and we're going to choose 3 of them. So we could do our, right underneath it, our 9, choose 3, which is going to be 9 factorial over 9 minus 3 factorial. So 6 factorial 3 factorial, which is 84. Now let me do the same thing for the students. So we're selecting 3 students. So there's 7 total students and we're choosing 3 of them. So that's 7, choose 3. So that's 7 factorial over 7 minus 3, so 4 factorial, 3 factorial. So that's 35. Now, by the fundamental counting principle, which we learned earlier in this chapter, if we have 84 ways of choosing the teachers and 35 ways of choosing the students, if we multiply those together, we'll get the total number of possibilities, which in this case is 2,940. Example 6. For a standard deck of cards, how many 5-card hands can be dealt having A, 4 diamonds? Okay, so let's think about that. We got 5 cards in our hand, so 4 of them are diamonds. So what that also implies is that we have 1 not diamond in our hand. So let's do the 4 diamond part first. So if I have 4 diamonds, what that means is, okay, how many total diamonds are there in a deck of cards? I made you this little picture here. So these are all the diamonds. There's 13 cards that are diamonds, and we're going to choose 4 of them. So I'm going to write that as 13, choose 4 for the diamonds. Now let me skip to this one not diamond card because we have 5 total cards in our hand. So the number of cards that are not diamonds are all of these, all of the hearts, all of the clubs, and all of the spades. So that's 3 more sets of 13, so that's 39 cards. So there's 39 that are not diamonds, and we're choosing one of them. Then by the fundamental counting principle, we can multiply those number of possibilities together, and we'll get our total number of possibilities. So I'm not going to show all the work here, but 13 choose 4 is 715. We're going to multiply that by 39, choose 1, which is 39. And we multiply that together, and there's 27,885 different 5-card hands that could be dealt, where you would get 4 diamonds and then 1 card that's not a diamond. Okay, let's try 4 cards of the same suit. So starting again with 4 cards of the same suit. So we think of ourselves, okay, we're choosing 4 cards. Well, how many cards are of the same suit? We just talked about this again. There's 13 cards of each suit. So we're still doing 13, choose 4 here. But the issue here now is that we don't know that it's what suit it is. Here we knew it was diamonds. But in this case, it could either be hearts, clubs, diamonds, or spades. So there's 4 options that we have to consider. So we're going to multiply that by 4. Finally, we have to take into account, again, we have 5 cards in our hand, so we have 1 card that's not in that same suit. So again, we say to ourselves, okay, we're choosing 1 card. How many cards would not be in that same suit? And again, here we would have 39 that are not in that same suit. So we would do 4 times 13 choose 4 times 39 choose 1. That would be 111,540. Trying a few more of these 5-card hand problems. So what about the number of ways to get a pair of 5s in your hand? So let's think about this. So we're going to have 2 5s in our hand. And then we still have 5 cards in our hand, so we basically have 3 not 5s. Okay, so let's write out our combinations here. So for the 2 5s, we're choosing 2 cards, so that number goes on the bottom. The number that goes on the top are how many 5s there are in a deck of cards. So if you look here, there's 4 different 5s. There's 1 for each suit. So we have 4 5s to choose from. Okay, now let's do 3 not 5s. So the number that goes on the bottom of the number of cards you're choosing, so we're choosing 3. And then we have to think about all the cards that are not 5s. Well, only 4 of them actually are 5s. So then all the ones that are not 5s are just not those 4. So there's 52 cards in a deck. So if we take out the 4 5s, that's 48 to choose from. And then that will give us our combinations for a pair of 5. So we do 4 choose 2 times 48 choose 3. And we're going to get 103,776. Okay, what if we didn't specify what type of pair it is? So this is just a pair. It's not a pair of 5s, not a pair of kings. We don't know what the pair actually is. It starts out very similar. You know, there's 4 of each card, and you're going to take 2 of them so that you actually have a pair. And then for the other 3 cards in your hand, you want to make sure you don't have any of that same card, and there's always 4 of each card. So we still have the 48 choose 3. But the difference is we don't know what it's a pair of. Is it a pair of aces? Is it a pair of 2s? Is it a pair of 3s? Is it a pair of 4s, 5s, 6? We have all these options, and we have 13 options. So what we need to do is multiply that by 13. And in that case, we'll get 1,349,088. Alrighty, this was lesson 15.7, so go ahead and check Schoology for your assignment.